Hello everyone. Today we will see about all graphs which is found on the survival analysis. So we will see all graphs. Now we will go to the data set. We will go to the cancer data, and yes, it is. So you will write first. Let me introduce about the data. So this is survival data. This is the time period, duration. This is an event, 1 and 0. 1 is having cancer, 0 is absence of cancer, and this is drug having 3 category. 1 is placebo, 2 and 2 is treatment 1, 3 is treatment 2. This is age, it's continuous variable. This is survival set. So already it has setted. Having this concept, okay, let me show you about the drug. It is independent variable, so it has 3 categories. 1 is placebo, 2 is treatment 1, 3 is treatment 2. So age is continuous variable. It's also an independent variable. So yeah, this is continuous variable. So there are 48 participants. So having this idea, now we will go to how to make survival graphs. So first let me introduce about the Cox regression model. To do binary Cox regression model. So we will see Cox SCT Cox, then independent variable drug. So we will add indicator variable. So this is bivariable Cox regression model. So to make multivariable, we will add I. No, I, it's continuous, so we will add age. So this one. To make also to do Weibull regression, we will change into SCT Cox into SCT rig. So this we will specify the distribution. So we will write Weibull. So we can add also, if you want, we can also add age. So yes, it works. So this is a Weibull regression parametric model. So if you want to add age, you can add to make multivariable Weibull regression. You can add age, then you can do this just like this. So others also will do just like this. So we will now make about graphs. So this is also important. So now to make first you want to hazard graph, you can write STS graph comma hazard. You can write STS graph hazard, so you can get an hazard graph. So survival times graph hazard. Yeah, this is a smoothed hazard estimate. This is a hazard graph. So if you want to do other type of graph, you can write for instance, if you want to if you want to change this one, it starts with 0.035, 0.04, 0.045, just like this. But if you want to this, you can change the level. So let me show you how you do that. STS graph comma hazard, then you can add y label. y level, then we will write 0.00, 0.5, 1.1. So now we are specifying the graph will be between the 0 and 1 by gap of 0.25, by interval of 0.25. so now we can do that. Yes, yeah, it will be, the shape is changed because 0, 0.5, 5, 0, by 0.5 it starts with 0 and ends with 1, so the shape will be changed. The other is if you want to make also cumulative hazard graph. If you want to cumulative hazard graph, you can change STS graph, then you can write cumulative hazard. Cumulative hazard, it will write just like this, cum hazard or cumulative hazard. So yes, cumulative hazard estimate is this one. So Nelson Allen cumulative hazard estimate. So this is time, this is hazard, so it will be just like this. It is known as Nelson Allen cumulative hazard estimate. So this is also another way of making survival graphs. The other is also you can make another type of graph also by changing, instead of cumulative hazard, by changing survival. You can STS graph survival. So now you will get just like this. So this one is Kaplan Meier survival estimate. So it is a survival. So as the time goes, survival time will be decreases. So this is also Kaplan Meier estimate. By the way, this is graph is similar with by writing STS graph by something variable, so y level. So this is Kaplan Meier survival estimate. So you can also this option, also another option. Also the other option is we can see, like let me also, if you want to Kaplan Meier estimate by variable, you can write STS graph by variable. You can insert here by the variable which you want to do that, or which you want to do the graph. So you can add this drag, that should be categorical variable. So y level will be this is also another type of Kaplan Meier survival estimates. This is also if you want to compare one variable with compare the categories of one variable. Maybe this has three categories, but if you want to do also variables which have two categories, like sex, having male and female category, so this is based on the three categories. So this one is drag 1, this one is drag 2, this one is drag 3. So the drag 3, so since our objective is days, time to days, so this one is having less risk for days, this one. But individuals who have taken drag 1 or placebo has high risk for days, but individuals individuals who have taken treatment series or treatment 2 or category series have less risk for death. So when this one is rapid time to recovery for this, so so we can compare just like this by graphically or by graphically. So for instance, this is female, this is male, this is female, this is male. So we can compare in male and female. So females are more at risk for death than for females. So Kaplan Meier survival estimates is very important for to compare two categories, categorical variables. So you can estimate just like this. So the former Kaplan Meier survival estimates is it estimates the survival, but this one is it estimates the survival, but between the category. If you want to between it compares the categories within the variable that you want to select. So this is another type of graph. The other is also there are also another type of graph called but if you want to do graphically, if you want to make proportional, if you want to test proportional hazard assumption graphically, you can also do that. So before to do that, you can run this SCT Cox regression model. So this is multivariable Cox regression model. So you can run this one, and after this you can write SCTPH plot, comma, strata, then you can insert the variable drag, then adjust for another variable. You can make age. So survival time, proportional hazard plot, strata, drag, adjust for age. So you can make strata by drag. So 0 x level 1 of 7. So by the way, Cox proportional hazard assumption, to check Cox proportional hazard assumption, we can check by two ways. The one is statistically. So statistically, we have seen last time by using the stat pH test command, and last time you can see the video which was made. Now we are doing also about checking assumption based on graphically in the last video. Now let me show you how to make graph to do graphical assumption. So you can run. So you will make just like this. So this assumption, it should be variables should be parallel. It should be parallel in order to fit, or in order to fit the proportional hazard assumption. So this is also another way of making graphs. So this is another way of making graphs. So the other type is you can make also after running this one, you can make also different types of graphs. The first graph is we can SCT curve. We can make Cox regression graph. So SCT curve, direct city curve, comma, survival at T1, at T2, at T3, then you can write the color. You can select S1 color. Yes, this is Cox proportional hazard regression. This is time. So this one is a drag 1, this one is a drag 2, this one is drag 2, this one is drag 3. So this one is drag 1, this one is drag 2, this one is drag 3. So this is also compare the survival. So this compare the three groups for survival. So this is also an important graph. You can do also just like this. Also you can add the fourth line. By the way, this is bivariable for Cox regression graph, bivariable Cox regression graph. But if you want to multivariable Cox regression graph, you can add h. So after running h, you can run this, and you can add this one, another variable at t4 is equal to h is equal to 1. So you can run. Yeah, you will get it now 4 lines. Yeah, this is 4 lines. This one is age 1, so age 1 is this one, age is this one is drag 3, this is drag 2, this is placebo, drag 1. So you can make just like this. The other type graph is you can make also Weibull regression graph. This is drag eccentric I drag distribution Weibull. This is Weibull bivariable Weibull regression. After this one, you can make also this one at T1, drag 1, at T2 you can make this one. So this is yes, this one is Weibull regression. This one is drag 2, this one is drag 3, and this one is drag 1. So the same, drag 3, this one is less risk for death, so drag 1 placebo is less high risk for death. So the same result will be given. So Weibull regression and Cox regression model this time estimates no far difference between them, so estimate gives the same finding. So this is also if you want to do Weibull regression. So if you want to graph for multiple Weibull regression, you can add age here. So this is multivariable Weibull regression. So you can do the graph you can write survival at T1, T2, T3, and you can add age, and you can make a graph just like this. So just like this. Now this is age, the age variable, so we can compare by this one, Weibull regression. So this is an important one. If you want to also doing by two variable, STS graph, comma, by two variable, you can insert drag and age, so we can write y level (0.001) and by distance of 0.5. Now you can write this way. Okay, Kaplan Meier survival estimates. That's why, because we used age is continuous variable. So to do Kaplan Meier estimates, the variable should be categorical. But the command is seems like just like this. You can do this way. So at any time, you can do graphs for this. So we have seen graphs for survival graph, Kaplan Meier estimate graph, and hazard graph, cumulative hazard graph, and also we have seen Cox regression model graph and Weibull regression graph for parametric. So these all are mostly we are facing when these graphs are variable when we are doing survival research or survival analysis. We can do one of them, or we can select one method from all variables or all methods. So this is all about the graphs which is found on survival analysis. Thank you very much for watching this video and for listening us. So to get the next videos and to get the next analysis or course, don't forget to subscribe to this channel, and thank you very much. Have a nice time. Bye bye.